Another data structure we are going to study is a binary search tree. Prior to studying it, we need to first understand the binary tree. So here is the definition of the binary tree. A binary tree is made of nodes where each node contains left pointer, right pointer, and the data. So if I draw a picture for that, a node has three components. So you have a data. Since a binary tree is like a stack and queue, it's a container, so we need a place to store data, and then it has two pointer. One pointer is called the left pointer, and then right pointer. And the whole binary tree is represented by a pointer points to the topmost node. So here we will have a binary tree. Then the binary tree, the first one, the topmost node is pointed by a pointer. So a pointer points to this one, and that is topmost node is called the root node. So we are keep defining what binary tree is. And then third, the left and the right pointers are recursively pointed to the smaller subtrees on either side. So left pointer is pointing to a tree. It's smaller size though. Right pointer is pointing to a tree. It may be smaller size though. And then last one is the null pointer, represent a binary tree with no element or empty tree. So here if I keep drawing, so left pointer is pointing to smaller binary tree, so it should have a node, first root node of the left subtree, and then it may have two pointers, left pointer and right pointer. And then the last one says that if the left pointer is null, then it's called the empty tree. It itself is a tree as well. And then right pointer may point to a smaller tree, and then it has a root of the smaller tree, and then left subtree and right subtree and so on. So recursively it's keep defined. So in summary, a binary tree is a set of nodes, and each node can point to two other nodes, and that node could be root of the corresponding binary tree. And then the whole tree, suppose this is whole tree, is pointed by a pointer. Pointer is simply pointing to the root node, which is a topmost node of the entire tree. So that's the definition of a binary tree. Then some formally we can define it as recursively. So here the formal definition of a binary tree recursively is a binary tree is either empty or it consists of a single node called a root node, where each of left and right pointers pointed to a binary tree. So we have a recursive definition. As I explained in the picture, the binary tree is either empty. If you don't have anything on the right hand side, this is just empty. That is a binary tree. Or if it's not an empty, it has a single node called the root node, and the root node has two pointers, left and right. So left and right points to another binary tree. It could be smaller size though. So we have defined the binary tree recursively. So the property of the binary tree is an empty one is also binary tree, which serves as a base case of the recursive algorithm. Then three nodes of binary tree could be root node, left subtree, then there's nothing on the right. Right subtree is empty. Left subtree, this is a root node, which has a left subtree, and right subtree is empty, nothing. So similarly, we have another example of a binary tree with a three nodes. So this is a root node. Left subtree is this one. right subtree is empty. In left subtree, this is root of the left subtree, and its left is empty, and here is a right subtree. Right subtree, this is root node, empty left, empty right subtree. This is another example, root node, left subtree, right subtree. Root node, empty left subtree, and right subtree. Root node, empty left subtree, and right subtree, and the like. So those are examples of three nodes binary trees. So binary tree have the following properties as follows. The binary tree has a finite number of nodes, and then each node has at most two children, left subtree and right subtree. So at most up to two, and then it could be 0 or 1 or 2. And each node has exactly one parent except for root. So we have root node and the left subtree and the like. The right subtree and the like. So except the root node, each node has exactly one parent. The subtree of a binary tree is a binary tree. So we have a recursive definition of a binary tree.